let me start catching up to you guys. So. What about 1a? Is that a function?
Yes.
Ooh, I got dissension amongst the ranks.
Yes.
So this is person number 5, and they're wearing a size 3 shoe. Person number 6 is wearing a size 8. It's all good. Nobody's wearing 2 sets of shoes at once. But yes, no x goes to more than 1y. Every x goes to only 1y. That's the key. So then obviously part B has a problem. This is the person that's wearing 2 sets of shoes on a foot. It's like, it's alright. You can do whatever you want to do, but that's weird. So this is not a function specifically because why? 5, input 5 has 2 outputs. All right, cool. So what about part C? It's really the same question, just written a little bit different format.
No.
And not a function, definitely not, because why exactly? 9 has more than 2 outputs. Right? Person number 9 is 1 foot away from me and 5 feet behind me or something. Who is this person? That's a good power to have. Am I in another reboot of Heroes? What's going on? So, not a function. 9 has more than 1 output. Coolness. And what about part D?
Yes.
Yes, it is a function. Check. No input has more than 1 output. I like it. Cool. And then the last way you could see it would be visually. Now, this is, to be honest, it's supposed to be a full circle, but my printer said, screw that, Jeff. But all it takes is one location where a vertical line goes through more than once, and it is not a function. That's the ball. Where's the ball? Where's the ball? Where's the ball? 2 feet up and 2 feet below me. What the hell kind of ball is that? What is that shit? I haven't seen that one yet. Not a function. Why? Because it doesn't pass. Yeah, it does not pass VLT.
What's that again?
See it?
What's the VLT again?
Vertical line test. And that's related to, when I draw a vertical line, I've gone through 1x. Right? Every vertical line goes through 1 x value, but how many y values does it go through? More than 1. Shit, so that's exactly the same as the definition. If I can go through more than one place with a vertical line, then that x has more than 1 output. Not allowed. What about this one? Yes, it passes the vertical line test. So we'll be allowed to do the Olympics, Maria. Okay. All right, and then this is the other idea. So this is related to just the basic definition of what a function is. And this is how to use functions. So how would I do part A? What would I do exactly? Into F11. So plug a -1 in to the F function. It's just substitution is the basic idea of that. So f of -1 would be twice -1, get out of the plus, -1. So f of -1 is -3. Bam. Can somebody tell me one point that the function f goes through? -1, comma, -3. See, that's another thing about function notation. You can actually see the whole point that it goes through. For an input of -1, the output is -3. I like it. I like it a lot. So what about h of 3? I just put a 3 in the h. Right? So that tells me which function to use. So h of 3 would be 3 squared minus 1. Yeah. I like it. So don't say h of x equals 8. That's not true. H of x is x squared minus 1. H of 3 is 8. H of 4 would be something else. H of 5 would be something else. All right, please. Now, please let that be nice. I mean, this is the most, you did this back in Math 88, like in the first month of Math 88, or that level class. They give you something, and they say, now, what if A is 2? Well, then you put a 2 in for A. That's exactly what this is asking you to do. Replace X with whatever the number is in there now. It's just substitution. G of 1. So again, I would take 1, plug it in every X I see. So G of 1 would be 1 minus 1 over 1 plus 5. 0. Don't just stop at 0 over 6. I need to make sure that you know that that's 0. Right? 0 divided by 6 is 0. So it's like you're telling me, here, Jeff solved this, and that's the answer. No, you solved it. You're the student. You solved it. Uh-oh. Scheisse. So remember, you can divide 0 by any number except 0. 0 over 0 really sucks. We're not even going to talk about that. It's just I can't divide by 0. That's the problem. I can divide 0 by anything. What about H of M? This is almost too silly. H of X is X squared minus 1, so H of M is M squared minus 1. Yeah. That kind of shows you that X, there's nothing special about X. They just chose X just because. They could have chosen M. We could be talking about M and Y instead of X and Y. Yeah.
Can we factor that, or not if we're graphing?
So we're not graphing anything. And to be honest, this one said what we're really doing here is simplifying. And what's really weird for students to understand is when I say simplify, that's the opposite of factor. Factoring is undo multiplication. Simplify is do all the operations. So if you did factor it, I'm not going to take points off. There's no need to, and it's kind of not the right time for that. This one threw some of us off. But remember, domain is what? What's domain? Good. It's all the values I can use for X. So I'm going to be a little more specific now. What's the one value of X I can't use in the G function? Negative 5. So I know before I said you could just write that.
So all real numbers except negative 5?
Good, I like it, but even better is what we're about to do.
And negative infinity?
Yes. So an interval notation, I would go all the way from negative infinity and I would have to stop at negative 5. And then there's this symbol right here. Has anybody ever seen this symbol here? This is the OR symbol. I love this symbol because I'm like, you or you, somebody do it. Shit. So that's the U, the OR symbol. So what numbers am I allowed to use? Everything up to negative 5 or from negative 5 up. So I always look at this as saying skip. It's all the real numbers, skip negative 5. That little middle piece, I always think of that as skip. Skip negative 5. That's what it looks like in interval notation. Alright, and then 3... Oh, sorry.
How'd you get negative 5 again?
So in G, what cannot happen? In fact, in any fraction, what can't happen? Any fraction, what can I not divide by? I can divide by negative only, right? 7 divided by negative 1 is negative 7. What can I not divide by? What's 7 divided by 0?
0.
No, it's not 0.
What is it?
It's undefined. Right? I can't divide by 0 because what times 0 is 7 is what. When I write this, the question is, what do I multiply by 0 to get 7? That's why 6 divided by 2 is 3, because if the question is, what do I multiply 2 by to get 6? The answer is 3. What do I multiply 0 by to get 7?
Nothing.
There ain't shit that does that. Is there anything defined to do that? So that's undefined. So, coming back. The domain is all the x's I'm allowed to use. There is a value of x that makes the bottom 0. And that value, and if you say the bottom can't be 0, solve the bottom can't be negative 5. I mean, the x can't be negative 5. Because that would make the bottom 0.
Got it. Thank you.
Sure. So we talked about this kind of idea here already. I didn't even tell you what the function is, but I want you to tell me what f of negative 1 is.
Negative 3.
Yeah, when I plug a negative 1 in, I must get a negative 3 out, because that's where the function went. So it's even better than me telling you, well, I've given you all the answers. Holy shit. Again, I become Scottish almost. What's f of 0?
Negative 3.
Yeah, for an input of 0, the output must have been negative 2, because I can see that's where they put the point. Let that be nice. What about the domain? Now be really careful. Why do you think I put these little dots here on some of these things?
You have an actual pinpoint of what we're talking about.
At that specific position. So what is f of 2?
6.
6. But does that mean that there is no f of 1.5? What's f of 1.5? What is it roughly? It's almost, it looks like maybe it is 3, right?
Yeah.
What about f of 0.12598? Looks to be about negative 1 point something, right? Do you see what I'm saying? Well, my point is, don't tell me the domain is negative 3, negative 1. What about everything in between negative 3 and negative 1? Don't they go somewhere? So what notation must I use? Interval notation, yeah. So the domain is going to be from negative 3 continuously all the way through 2, because 2 goes somewhere. So your domain is all the x's that have outputs. So the range must be,
Negative 3 to...
yeah, all the y's that are those outputs. So the smallest output I see is negative 3, and the largest output I see is 6. Bam, nothing is skipped. That's all domain and range are. Domain is look at the x-axis. Where do I see outputs? Range is look at the y-axis. What are those outputs? Okay. So that first section should be relatively simple. And to be honest, I'm not going to talk much about 8.2 at all, because I'm a math teacher and we suck. No, because 8.2 is a review. 8.2 is just linear functions. So one thing I want to talk about from this section, this is all very familiar, slopes and so forth. We've already talked about those kind of things. The only new thing, the only semi-new thing here is this. Can somebody give me an example of something that's not a linear function? Something that's not a linear function. So let's start off this way. Give me an example of a linear function. I love it. That's too general. Give me a specific example of a linear function. Do it again.
Just 2x, something.
I like it. So y equals 2x. That's linear. Give me another one. Y equals 3x. Y equals 3x minus pi. That's a linear function all day long. Y equals pi x minus the square root of 11. That's a linear function all day long. Gross linear functions, I don't want to graph those damn things, but they're linear.
What about y-intercept?
Huh?
Like the y-intercept?
What's the y-intercept of this one? Negative root at 11, right? 0, negative root at 11. This one, negative, 0, negative pi. This one, what's here? 0, 0, 0. So the key is they have to be able to be written as y equals mx plus b. So what's not linear? Give me something that's not linear.
X squared.
I love it. Y equals x squared. It's dead in the water. Can you write it as mx plus b? There's too many freaking x's there. So linear means that your variables are to the first power. The y is to the first power. Any x's are also to the first power. Where does this equation go? Is it linear or not linear? Linear all day long. What's the slope? 0. Kick ass. Y equals 5. Is that line? Yes. I love it. Because there are no y's or x's to a higher power than 1. There are no x's. So you can't go wrong with that. So the key there is, if I see stuff like y equals x squared, y equals square root of x, y equals absolute value of x, oh shit, we got to talk about that. Those are not linear. When I graph them, they're not going to end up being just one straight line. Okay, I like it. Okay. I think this is where they talk a little bit about No, not yet. Absolute value comes in here in a little bit, I guess. Okay. Cool. So the main thing I want to focus on with the time left is section 8.3. Maybe I should just keep going up here. Got it all set up. All right. This is kind of related to that whole U symbol I used in the last problem on that, or one of those problems, Cameron, on the handout. So let me get you guys to remind me how to do something like this. How do I graph 2x minus 1 is greater than 7? Take a minute and try to get to the point where you can graph the answer to this. See him?
The question.
Yes.
Find the answer.
No, get the answer and graph it.
Oh.
Yeah. So make sure that we all remember how inequalities work, because now we're going to be doing things where they give us two inequalities at once. So of course add 1, divide by 2. Is that cool? Graph it. What do I put on the 4? Parenthesis. Now, how do you write that in interval notation? Good. Parenthesis. I like it. The smallest it could be is 4, and I don't want to include 4. And what's the biggest it could be? Well, yeah, it keeps going forever, so we represent that with infinity. Always a parenthesis on infinity, unless you attain nirvana. I probably won't see any more after that, so you couldn't even tell me about it. Shit. Okay. But if you reach nirvana, it's a good reason to not come to class. Alright. Enough of that weird ass stuff, Jeff. Now let me ask you this. How many of you guys are women? Raise your hand. I love it. You gotta know what the hell's your question. Alright. How many of everybody has ever seen a hockey game? Ever? Okay. How many of you are women and you have seen a hockey game? Raise your hand. Thankfully, no men. I am, but showing you how to raise your hand, I guess, is what I was doing. That last question, did it have more or less hands raised than the other two? Less. Why? Exactly, it's more specific. You gotta meet both requirements. So, what have I said? So how many answers are there to this? Infinite number. I love it. So, I'm going to cut that down a little. It's still going to be an infinite number. But what have I said? Not only do my answers have to match this, they have to also, and they have to match this. Let's just make it like this, Jeff. Let's just cut to the chase. X less than or equal to 8. What would that by itself look like?
So it would be 4, 8.
I love it. So this by itself would look like this. What would go on the 8? Bracket, because it's allowed to equal. So if I wanted to have to do this and this, that goes forever down, but this stops at 4. This goes forever up, but this stops at 8.
Your answer is between 4 and 8.
I love it. So the answer would be from 4 to 8, like that. Those are the numbers that work in both. So and will always decrease the amount of stuff that I had. Just like when I said and, it was only the women that had seen a hockey game that still had a hand up. It's less. Right? So and is going to decrease. So it didn't let it go all the way up to infinity. It didn't let it go all the way down to negative infinity. It stopped on both edges. You guys get the idea. So for example, does 9 work here?
Yeah.
Yes, because it goes forever up. 9 works here. Does 9 work here? No, so that 9 cannot be in the answer for both because it doesn't work in both. maybe. So it's sort of like a one-dimensional analog to, remember when we were graphing and shading one side and then looking to see where the shading, it's sort of like a one-dimensional analog of that. Where do the shadings overlap? From 4 up to 8, that's where they overlap. Okay,
Any number?
say again?
Any number? Because I'm doing my homework, I start with number 15.
Sure.
So it's 6 and 7 works, so both of them?
Wait.
Number 15, section 83.
Oh, alright. Well, that one's a little bit better than this one.
I know, but 6 and 7 work. Both of them.
For number 15? Sure, 6 and 7 work, but that's 2 out of an infinite number of answers.
Yeah, because
I'm not sure. So 15, all 15 says is put this in your interval notation. What would that look like in interval notation? So what goes on the smaller end of the comma here? What's the smallest it could be? 5. Do these a bracket or parenthesis? Parenthesis, because it's not allowed to equal it. Up to 8. Bracket. So really that part of the homework is just, do you know how to put together interval notation? That's really what the point of that is. Yes?
I don't know if it's relevant at the moment, but when we were doing the shading, I thought that when we had the greater than or less than, greater or equal to would just be the dotted line instead of...
Oh, no. This is the one-dimensional analog to that. This is only one variable here, right? X's. It's not 2 dimensions.
Right. If we did a graphing thing before, I was recapping that the line is 2 dotted, right?
If I'm doing like x plus y greater than 7, if I have 2 variables, then I do need 2 axes. And then I am breaking them up with the line. But now, this is like my dotted line. Right? A parenthesis means I don't include the 4th. So dotted line means I don't include the points on the line. That's what that means. I like it. Alright, so now we're back. These are actually, in a way, should be simpler because it's only one axis that I need, not 2 axes. Okay, some of you guys are kind of with me. Some of you guys are like, what the hell, more shit? Alright. So they have a whole little section that kind of gets at this a little bit quicker. So, for example, if I said x less than -1 and x greater equal to -3, see who can just go right to the answer. So x less than -1, that goes down forever, right? X greater than or equal to -3 starts at -3 and goes up forever. So what does both? What numbers do both? What's the smallest number I can use then?
-3.
Yeah, so for example, so if you want to give yourself a little picture of what's going on, -1, -3 and -1. So this guy starts at -3 and goes up forever. This guy starts at -1 and goes down forever. So this is kind of nice when you do this visually. Where do they overlap? And means they have to match. So from what to what?
-3 to -1.
So from -3 to -1. What's on the -3?
Bracket.
Yeah, because it's in both, isn't it? -3 is here and here. What about -1? Good, because it's not there. So it can't be in the answer. Bam.
That's okay.
Sure. Alright. So there's a whole little section that just go right to the heart of things, giving you both of these solved already. That's kind of nice. More paper. I need more paper. So what about or then? Well, see where they, oh, here we go. Here's where the first 2 or. So what if I said x is less than or equal to -5, or x is greater than 3? This one's easier.
Don't they normally have like an equation for us to be able to put that in, or what about how?
Well, this is getting right to the point. I mean, it's already been solved. Right? There's a whole section where it's just already solved for x. It's just asking, do you understand what and means and what or means? So some of these will start off with equations like this one did. Well, you just solve it and then you do exactly what we're doing. Right? Solving it shouldn't be the hard part.
So there's a section in the middle that there's just nothing. So
Yeah, it looks just like this. Exactly. Yes.
Oh, never mind.
Sure. I can do that. So what does or mean? So if I said, raise your hand if you're a woman or you've seen a hockey game.
So, anybody?
It's more.
Whoever, I've seen a hockey game, so I can raise my hand. I know I'm not a woman, but you said or. So or is going to be making things more. So not only could it be less than or equal to -5, it could also be greater than 3. It's like either one. I'll take all of you. Right? I always call it the nice bouncer. I don't know if I've done the bouncers in here yet. You could be rich or have a nice car or know Tony, the bartender. Oh, thank God, I know Tony. Then come on in. Right? The evil bouncer's got to be rich, and you got to have a nice car, and you got to be dressed nice, and you got to know Tony. Really? Okay, get away. That's less and less and less people can go into the and bar. More and more people can go into the or bar. You with me? And look in there, it tastes just as good. So it's all good. All right. So this one, if I wanted to graph this, not only can it be that, it can also be that. So what would this interval notation look like? I already showed you an example of this earlier, but it's different from what we're used to. It's two separate sets. So not only is it from what? What would this be? From negative infinity up to -5, or to infinity. I like it. So or includes everybody, and says, I'm only going to put you in the answer if you are in both of these. Or says, you could be the answer if you're in either one of these. So hopeful. So desperately hopeful. Alright. Blah, 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 blah. Yeah, okay. And it's not a bad idea to do it, to graph it if you have any trouble with this, because once you see it visually, for example, I think when people see this, even though I can't draw very well, it's very explanatory, because now you can see, oh, it's in here where it's and. This one and that one agree there. That's why the answer is this. That's where they agree. Or is like everybody come on in. So real quick, what would this be if I had the same inequalities, but I said and? Which numbers are less than or equal to -5 and bigger than 3? They have to be less than or equal to -5 and at the same time bigger than 3. None. I love it. So we actually would say that's the empty set. I don't know if you ever saw that. This is what's called the empty set. Aw. Ain't nobody in it. I like it. So and sometimes can have no answer because there's nobody that's in both. I like it. Okay. Let's see if I missed anybody. Oh, one little thing. So the first part of the homework looks like this. And there is a bit of this mixed in, but the second part focuses on this kind of thing here. And this should not be a big deal. Yeah, whatever, Jeff. That should not be a big deal. How do you solve that?
I think it was two separate.
You could, but I'm desperately going to make you not do that because you so don't have to. What would I do there? What would I do to solve that? Add 1 to both sides. How many sides do I have now? 3. Left, right, and in side. So if you add 1 to 1, you got to add 1 to all sides to maintain the equality, the inequality in this case. So then I get what?
-6. 2x.
Good. And then the last thing, divide by 2. Get the x by itself as always. Just whatever you do to all sides. And of course, graph it. What's on the -3?
Bracket.
Bracket. Right, see? And then that's exactly what it looks like. Interval notation. Yeah, there. Bracket. There. That's really why we don't use open and closed circles anymore, so that it goes right into interval notation real easy. I think that's all the weirdness in section 8.3. You just got to try those out, and I think graphing those and or problems are going to help you out a lot, trying to figure those out. So the very last thing to do very last thing for today. You guys are like, I thought that was blessing. No, you're wrong. You're drunk bless. Remind me, I think we talked about this a little bit already, but we got to look at it a little bit further. What was the absolute value of 3? 3. We already have something that changes the sign of something that's known as multiplying by a negative. So absolute value has to mean something different. So absolute value, why is it always... So what's the absolute value of negative 3?
3.
So what's the absolute value always do? This is an evil question. Makes it positive, but if it's already positive, what's it do?
Positive 0.
I love it. That's what the absolute value tells you. I'm asking you right now, what does it do? So these are both 3. What's up?
I said it's pain in the ass.
Oh, you gotta love absolute value, right? The answer is always positive it, right? So 3, the absolute value of 3 is 3 because it's